Okay, so one of the things that you have to contend with when you are building a design is forces. Okay, so this whole video is on what forces impact your design. A force is basically a push or a pull of some sort on a structure. Okay, normally when we describe a force, we describe three things. We describe its magnitude. Okay, so typically nowadays we give the magnitude in newtons. We give the direction of the force. Oftentimes this is given as vector. And the point of application. So this is the location where the force is applied. Now, think about it this way. Typically we see a force as, here's my structure. I'm going to apply the force here. I'm going to apply the force in that direction. And that force is going to have a certain number of newtons, right? So how big is the force? What direction is the force going, and where is it applied? Now, that's pretty much the three pieces of information that you need: the magnitude, the direction, and the point of application to understand any given force. Okay, so those are the three things that we like to describe. Okay, we have both external and internal forces on a structure. So we're going to talk about the external ones first. External forces are also sometimes called loads. Okay, and you have like two types of loads. You have a dead load, which is the effect of gravity on a structure. And you have live loads, which is basically forces that move or change when the structure is in use. So imagine like a bridge, okay? So here's my bridge. Connects to like, pieces of road that are connected by some sort of opening. The downward force that's exerted on the bridge at any given point is what is called its dead load. But if I were to, let's say, put a truck on the bridge and have the truck drive across, so there's my truck on the bridge, the truck is driving across, then the forces that are being exacted by this truck are live loads, because they're not forces that are being affected by gravity on the bridge itself, but they're being caused by the use of the bridge. Other forces that could happen here could be things like wind shear, could be pushing the bridge and causing some sway, or if like two vehicles have a collision on the bridge, does that impact cause like some vibration on the bridge? Those would all be examples of live loads that the bridge should be able to withstand if it's correctly engineered. And we also have internal forces, which feel like it's like a little bit odd to call them internal, but they're actually things that are forces that act upon an object from inside. Okay, so like there's nothing that is, the force itself is happening inside the structure. So one of them is that, like, you can compress. Okay, so compression is a force that so the force that squeezes or presses something together. Okay, so what's happening here is that the force is completely contained in the object, but it may be exerted, like the pressure may be exerted from outside, but the force of compression itself is inside the object. The opposite of this would be if I take an object and I try to pull it apart, then the force that's exacting inside the object here is what we call tension. Okay, so when I pull on the object, the force inside of it is tension. When I push on the object, the force inside of it is called compression. Another one that happens is if I have an object and I'm pushing one way on the top and one way on the bottom, I get a force on the inside here where you get like this, like I'm feeling pulled in two different directions. We call that shear. Okay, it's usually exerted by a push, could be exerted by pulls. You could be pulling the top in one direction and the bottom in another, and you would get what we call shear. And the last one is the idea that we're going to take part of the object and we're going to have it like stand still, and then we're going to take the top and we're going to twist it, right? So what's going on the inside of the object is what we call torsion. Okay, so the motion inside of twisting is torsion, right? So like if you kind of think there used to be a kids game out there, compression is bop it, tension is pull it, torsion is twist it, and shear is kind of like, I don't know, like the idea that you're pushing forces in two different directions. So the same thing is feeling like it's like when you take a pair of scissors, right? If you take a pair of scissors against something, the one part of the scissors going down, the other part of the scissors going up, the piece of paper between it is going through a shearing effect, and what actually causes the paper to separate is the shearing. So maybe it could be cut it, right? I like that idea. Cut it, like as if you had scissors there, might be a good way to look at that, right? So when you're thinking of shears, thinking of scissors, because the two things are pushing in opposite directions and causing part of it to be moving one way and part of it being moved the other way. So that's what we call shearing. Like people actually shear grapes and shear sheep. These are all that type of motions. Usually you end up cutting something off when you exert enough shear force. Okay, so there we go. These are forces that you need to deal with in designs, and we'll talk about these more in class, and we will pull them together maybe in a quiz later on. Okay, thank you.